Hey everybody! In this tutorial, I'm going to show you how to get started with implementing your own AI in Unity. So as you can see, we already have our scene set up and we have some ships. And if I was actually to look at these ships inside our hierarchy, they have some components which enable them to be controlled, and they have oriented physics. So if you're not already at this point, please go ahead and go back through the tutorials that will get you up to this point. So now the first thing we're going to want to do is create an AI manager under our managers. So I'm just going to do create an empty game object, and I'm going to name this AI manager, or MGR. And then I'm going to create a script now that's named the same exact thing, AI MGR. And then I'm going to go ahead and attach that script to this game object. And then now I'm ready to go ahead and implement this AI manager. Now that we're inside our AI manager in Visual Studio, let's go ahead and start off with creating our variables. So the first most important variable we need is a public static AI MGR instance. So this will reference to this class from any other script as a singleton. And we can set the value to instance just through the awake function. So private void awake instance equals this. Now we could access this variable from any class. All right, so the next thing we're going to want to do is go ahead and implement our update function. So let's start off by detecting our right mouse button down. So you could do that by accessing the input class. Input dot get mouse button down. And it's wanting a parameter of int, which specifies the button on your mouse. So 0 is left, 2 is middle, and 1 is actually your right mouse button. And then let's create some structure to that if statement. So then the next thing we're going to want to add is a physics Raycast. And to do that, let's just go ahead and type if physics dot Raycast and camera dot main dot screen point to ray screen point to ray, which is going to take a whole set of parameters itself. So this will be input dot mouse position. So that's a 2D position, but it says vector 3. And then the next thing after that is going to be out hit, wherever that hits in the world. And it's probably going to try to autocorrect. And right here you'll see that the name hit does not exist. So we actually got to create a variable for hit. I'm just going to create that right above the update function. And hit is actually a Raycast variable, Raycast hit. So just type Raycast hit and type hit, and then you'll see the red line go away. And then next, we're going to want a float dot max value. So that's pretty much infinity for float. And then the last thing it's asking for is a layer mask in the way we're doing it. So I'll explain layer mask later, but let's go ahead and type it out. Layer mask. And as we can see, there's red squiggly lines, so we need to define what layer mask is. I'm just going to create a new public variable called int layer mask. Okay. And then now there's going to be some contents to this if statement. So pretty much what we've done here is we've created a Raycast with these parameters, and whether or not we intersect with a collider, then this function will return true or false, and we can proceed with some more logic with inside here. So now let's go ahead and see the Raycast within Unity. And to do that, I'm going to use the Debug class. So if I type debug.drawLine, I'll actually be able to render a line within Unity that represents this Raycast. So we can make sure that we are clicking on a collider exactly where we intend to, and we can make sure that it's hitting in some exact point that we prefer. So the first parameter of this is going to be the start position. So we want to start from the camera main position. So we'll access the transform and get its position. And then the second parameter is the end vector 3, which is going to be wherever this hit collides with in our world. So you could do hit.point, and that should be good enough to draw a line. But there's several overrides for this function, so I'm going to go ahead and add a little bit more. So it says the next parameter is going to be color, so I'm going to specify the color class and access one of their predefined colors, which would be yellow. I'm just going to use that for debugging. And then another parameter is duration, so I want this line to be visible for 2 seconds. Alright, so before we actually proceed back into Unity, let's go ahead and define this layer mask value. So within the start function, we could type layer mask equals layer mask dot get mask, and we're going to define this within Unity, and we could call this ocean, and just go ahead and end that line. So layer mask is essentially like a filter. We could filter out several objects within inside our scene, and we can make sure that we only focus on like one single layer within Unity. So if I go back into Unity right now, you can see whenever you select a game object, there's like a layer drop down next to it. So let's go ahead and select the ocean game object. And when I have that selected, we can see that we have a few of these already like predefined by Unity. But I want to go ahead and create my own. So I'm going to click on Add Layer. And you can see that there's now 31 slots here, or 32 to be precise, because we're starting from 0. These first 8 are allocated by Unity Editor. So we can't really do anything with these. But under 9 is available, so I'm going to go ahead and give this a name called Ocean. Exactly how we typed it inside the script. Okay, so now we should be able to filter onto layer 9, and anything with Ocean should return us some results with our physics raycaster. So now let's go ahead and click on our ocean again, and let's select the layer, and then we can see that the ocean layer has popped up. So select that, and then yes, change children. All right, now let's go ahead and run our simulation. And if I look inside the game window and I start right-clicking, within our scene, we should start seeing yellow lines. But I'm right-clicking right now, and I don't see anything. So the reason for that is our Raycast function must always hit a collider, and currently we don't really have any colliders in our scene. So we could create a collider within our ocean game object, or we could create it within our AI manager game object, but I'm going to go ahead and create it inside the ocean game object. So I'm just going to do add component, and you could type box, and then you'll see a box collider 2D, but we're doing a 3D game, so box collider 3D. So right now there's a box collider at the origin of this game object, but it's really, really small. So we want a really, really big game object box collider, so that way we can raycast and collide in several areas. So I'm just going to up the size by 10,000 in multiple directions. Okay, and Y, I'll just leave it with 1. And then I'm just going to lower it a little bit. I'm going to lower this box collider down by 10. So that way it's not constantly colliding with other things, like ships sailing on the sea. So that should be pretty good. So now, if I go ahead and play, and I right click inside the game, now we can see there's yellow lines that are rendering for 2 seconds, and it's showing exactly where I'm right mouse button clicking. Okay, before we return back to the Visual Studio to keep working on our code, I just want to show something pretty cool with the layering. So if we look at add layer again, we can see that there's 32 values, or 32 possible slots. And Unity stores all these layers as 1 byte, so it's pretty small in memory. And 1 byte is equal to 8 bits of binary. And if I actually pull up my calculator, I could use bit shifting to navigate between different layers. So if we want to do a really low level operations to access different layers, we could do that within our code. So I'm actually going to show this post real quick. So as you can see within the layers, they all have a integer value representation, and it shows how you can bit shift to get to that layer. So if we want to get to layer 9, which is one we put our ocean on, it has an integer value representation of 512, and we'd have to shift our bits by 9. So if we look at a calculator, I'm going to go ahead and insert 1, and then I'm going to bit shift it over by 9, and then that equals 512. So now if we go inside Visual Studio, rather than getting the layer mask, ocean, we could just bit shift a value of 1 by 9. And now, inside Unity, if we play, we'll see that we're still raycasting just as we were a moment ago onto the layer ocean. So anyways, now back inside Unity, or inside Visual Studio, let's go ahead and start adding some more functionality to our raycast function, or method, or logic. And right after we debug our line, let's go ahead and type vector3 pose. And let's actually extract the position from where our raycast is hitting the world, or the ocean. So we could do that by just typing hit.point and set that equal to position. And no matter where that position is, we just want to make sure that we tell the ships to go there on the y-axis at 0. So to do that, you can just do pose.y and set it equal to 0. And then now let's go ahead and find the closest entity in a radius. So to do that, we're gonna need a helper function. So yeah, before I actually even try to do anything here, I'm just gonna go ahead and create a new function, and that's gonna be public entity 381 find closest ent in radius. Vector 3 is going to be the position, and or we could use point. And float, we're going to need to essentially square root. Okay, and then the second parameter is going to be the radius of how far we're going to check. So I'm just going to type radius. And then let's go ahead and add some brackets to that function. And then right off the bat, let's go ahead and make sure we have an entity 381, which this is going to be the closest entity that we find. And let's just start off with some null entity. And then we're going to need the distance of that entity, which we could call min distance, which will equal float.max value. So we'll set it essentially to affinity. And now let's go ahead and iterate through every single entity for each entity 381 and in entity manager dot instance dot entities. Okay, so now we're looping through every single entity inside the entity manager, and we're putting it into this variable. So then next, let's go ahead and let's calculate some distances. So to get the position distance, we're going to do ent.position minus point. So this will result in some vector 3. And we could do several methods on vector 3s, but I'm going to do magnitude to get the distance. And let's go ahead and check that distance. So if distance is less than our min distance, then let's go ahead and set this new distance, which we could actually go ahead and just assign that to this distance to some variable. So I'm going to type float entity position minus that will equal some distance. And end that line. And let's not calculate this twice because this is quite expensive. And then I'm going to set that here. And then now min distance is going to get the new value of distance because it's pretty close, or it's better than this min distance. And then I'm also going to assign the entity, so min ent is going to equal the current entity that we've iterated over. All right, and of course we're returning back some entity, so let's just go ahead and return the min ent here. Now, every time we go to click on our ocean, we want to find the closest entity in a radius, which will always be the same radius for every single entity. So, since we're using the same radius, we could go ahead and just define a variable for that, and I'm going to call it public float click radius. I'm going to set that equal to 100. And up here in our function, if we want to go ahead and find some entity that's within our click radius, we could do that by typing entity 381 and ent, which will equal find closest entity in radius from the position where we hit on the ocean, and then set it to 0, and the click radius that we defined down here. So before we go any further, I want to actually show something that's pretty cool that we could do to save memory and make our game run faster. So as we know, if we're trying to get the distance between 2 points, we have to square root the x, y, and z components squared after you've subtracted each one of them respectively. So the square root on this whole operation is quite expensive. So if we could completely bypass that square root, then we can help the machine code run faster. So a cool way we could do that is we could actually just square this value. So if I was to square it, that brings it up to 10,000. And then when we go and calculate the magnitude here, so the magnitude is with the square root. So if we want to completely avoid that square root, then there's actually a different function called SQR magnitude, square magnitude. So that's before you've square rooted everything. And then now let's just change our parameter here to make sure that it's following the square root, or the squared everything, so radius squared. And then we're going to have to adjust it anywhere inside this function that it breaks. One thing I forgot, we actually have to make sure that we are only capturing entities within this radius. So if no entities are within this radius, then we should return null. So in order to do that, we could just go ahead and check distance if it's less than our radius squared. Just like that. And then, of course, some brackets. And let's go ahead and nest everything inside that. So now, we actually still have to adjust a few things. So now this distance is now distance squared. Which then makes this min distance also squared, but that's okay. We'll just leave it at that. So yeah, now we should be able to capture entities within this radius after we've squared the distance and completely dodged that whole square root altogether. Now let's go ahead and wrap up this update function. And something I didn't do earlier, which I probably should have done. So whenever we don't collide with something, let's just go ahead and print out a debug message. So debug.log, we can say right mouse button did not collide with anything. Okay, so after we've captured our entity from this function, our focus entity, let's go ahead and handle some conditions with it. So if entity equals null, so not all the time we're going to capture an entity. So when we don't capture an entity, we should just like right click on the ocean, and then we could add like a command like, for example, like move to or something. So let's go ahead and check if the player or user is also holding a key. This will have its purpose later. Keycode dot left alt, just like that. And within here, we're going to have an else condition. So if the user is not holding alt, then we'll do something else. And then we're also going to have the opposing condition for if we actually do have an entity. And if we do have an entity, let's go ahead and check if the user is holding get key code left shift. Okay, and this will have its purpose later. Else, and we'll do something else in that case. So now your code should look something like this. And right here, so if the user is holding the left alt key and they right click somewhere on the ocean and they don't get an entity there, then let's go ahead and just teleport the entity there with an AI command. So I'm just going to type teleport command. And then if they right click on the ocean and there's no entity, then let's just go ahead and move command. And if they do have an entity that they've right clicked on and they're holding shift. Oh, actually, you know what? This should be control, because I believe shift is actually occupied by something else. So this should be left control. So if they're holding left control and they get an entity, then we should, at this point, intercept that entity. Entity intercept command. And then at this point, let's go ahead and follow whatever entity we found right here. So for the purpose of this tutorial, I'm just going to go ahead and implement the teleport command, and I'll leave the rest up to you. So let's go ahead and create a helper function down here, and we're going to call that, well, it's going to return nothing, and let's call it handle teleport. And it's going to take one parameter, and that parameter is going to be the position from our hit point. So let's do vector3 position or point, and then within here we're gonna have to create a command, and it's gonna be a teleport command, which it just wants to override teleport. We'll implement this later in a few moments, and let's go ahead and type new teleport, and the parameters for it, its constructor is going to be selection manager dot instance dot selected entity, and the second parameter is going to be that point. Okay, so we're going to create a teleport right there, a teleport command. This is one of the children classes of the abstract command class, and then unit AI. We need to get the unit AI object, which we haven't created yet, so let's just go ahead and assume that we have it. And this is going to be selection manager dot instance dot selected entity dot get component unit AI, just like that. So every single entity is going to have its own unit AI, and we're going to have to get that component so we can add a command onto it. And we have to check here if the input dot get key code equals left shift. So this is why we didn't occupy it up here. And if we're holding left shift, we just want to add the command onto the top of the list of the commands, or into the queue, the back of the queue of commands. So you could do that using the UAI dot. There's going to be a function inside there called add command teleport. We'll pass in this command, and then if we don't hold shift, let's go ahead and add a command. But instead of adding, we're actually going to set command, which will clear the queue of commands and put this as the very first command. Just like that. Okay, and before we wrap this up inside Visual Studio, let's just go ahead and handle the teleport right up here. So if we're holding left alt, we're going to do hit.point. We're going to call this function with the point passed into it. Okay, so now let's go ahead and get rid of these red squigglies. So now back inside Unity Editor, let's go ahead and create a abstract command class right alongside all our other scripts. Command, just like that. Okay, and once your command is created, then you'll see that there's probably quite a few errors from your AI manager. Just ignore those at this moment. So go ahead and open up this command script. And the functions we're going to need out of here are not these ones. So I'm just going to go ahead and delete them. And this class is actually not going to inherit from monobehavior. So I'm just going to go ahead and delete that. And let's make it serializable so that way we can see it within the Unity editor when we're inside the inspector. So I'm going to type serializable, system.serializable. And then the properties we're going to need inside this class are going to be the entity 381 entity, and then we're going to need like a constructor for this. So I'm just going to do that by typing public, the name of the class, command, and then the parameters coming into it, which is going to be some entity 381, and I'm going to call that ent. And then within this constructor, I'm just going to assign this entity value that we set up above, and I'm going to pass the parameter into that this data type. Okay, and then next, let's go ahead and add some other functions that we're going to need, which are common across all our commands. So we need a public, void, and init for initialization. We're going to need a public, void, tick for iterating. We're going to need a public bool is done to check if it's done at a certain point within our code. And then we're going to need a public void stop to just cancel the command no matter what. And since this is a bool, we need to return some value. So let's go ahead and return false. And then since this class is basically abstract, we're going to override all these in other classes. So let's just go ahead and make each of these functions virtual. Except the constructor function. Just like that. And just save your file, and we're pretty much done here. Next, let's go ahead and create the teleport subclass of command. So I'm just going to go ahead and right click and create a new C# script and name this one teleport, and open it up within Visual Studio. And now you could go ahead and delete those start and update functions, and then let's just make sure that teleport inherits from our command class, just like that. And then we need to create our default constructor. So to do that, let's type public teleport entity 381 and we're actually going to pass in a position, which is a vector3 position. And then let's make sure that whatever values from the base class will be transferred into this one, or we'll transfer the entity entity parameter into this base class, the command base class. Yeah. Okay, and then let's set a position, which we have to actually define in a variable up here. I'm going to type public vector3 teleport position is going to equal nothing. And then set teleport position equal to pose, whatever position is passed in right here. Okay, so now let's go ahead and override these four functions. So an easy way to start that off is just go ahead and copy them, and you could paste them directly in from the command class. And then let's go ahead and search for this keyword virtual. And you can do that by typing or pressing Control F on your keyboard. And then you could toggle this drop down, and then it's gonna give you the option to find and replace. So anywhere we find virtual, let's go ahead and replace it with override. Just like that. And then if you click replace all, then it should just update all of those. And then you'll see all those warnings go away. Okay, so our teleport command is going to do pretty much nothing on initialize, but we can at least like give a debug message. So let's type debug.log teleporting t to let's just go ahead and add our teleport position onto there. So this pretty much concatenates the string form of this function, and we don't have to worry about converting anything because C# is pretty good about that. And then next, let's go ahead and implement our tick function. So for this, it's just going to be entity.position is going to equal teleport position, just like that. And then next, let's somehow check if it's done. So each of your commands are going to have like slightly different implementations of each of these functions, and even this function as well. So move will look pretty similar to this, where you pass in an entity into the constructor and then also a vector3 position. But when you start doing like follow and intercept, you actually pass in like your current entity and then the target entity. So it'll be slightly different, and each of these will vary just a little bit. So good to know. So now let's go ahead and create a public variable for a public vector3 called difference, and this will just hold our difference in positions, which we're going to call we're going to set the value to positive infinity from this vector3. So it's going to set the largest possible vector3 we could possibly acquire of floats in all three of those positions. And then we're going to need another value, and let's call this one public float done distance squared. So just like before, rather than like normally it'd just be 10, but let's just go ahead and square it up so the machine code isn't doing that behind the scenes, and we're optimizing the performance. And then now let's go ahead and calculate the difference in position. And the reason why we store the difference in position as a public variable like outside of the function, so that way we're not like constantly recreating this difference vector3 every single frame, or that this is done function is called. So if we could just store it out here, then we're not like adding on to the stack of memory or heap or whatever is happening under the scenes. So then now we take our teleport position, subtract it from the entity position. So now we have our difference vector, and then let's just go ahead and return some logic, and this logic could be difference dot squared magnitude, just like we did in the AI manager. And let's check if it's less than done distance squared. Okay. So essentially, what's going to happen is we're gonna add this command, and we're gonna teleport the entity position to the teleport position after one tick, and then we're going to check if it's done. And if it is done, then we're going to return true. And then it should be popped off the queue of commands, and then your next command will be processed from the AI commands. Okay, so we're finished with this. Let's go ahead and save this script and return back to the Unity editor. And then we should see some error messages go away, but we're still missing our unit AI script, which belongs to each entity 381. So to create that, just go ahead and right click in your Explorer or in your assets, and let's create a new script. I actually put that in the wrong place. Let's go ahead and delete that. Let's go create a new C# script. This is going to be called unit AI. Okay, unit AI. And then for the purpose of this tutorial, I'm actually not going to show you how to implement this. This is going to be left up to you. So just remember that the unit AI class will actually just be keeping a list of commands, and it will iterate through each of those commands, or not each of the commands, it'll iterate through the first command each update, and it'll check if it's finished, and if it is finished, then it will remove it from the list, and then you can proceed to your next command. Or sometimes you can actually have all the commands like removed, and you'll start from a clean list depending on when that function is called. So that's pretty much the bulk of this. So sorry I can't share that code with you. So now that you've finished your unit AI, when we come back into Unity editor, we should see that all the error messages go away. Still seeing this one. Oh, okay. So I accidentally typed unit AI as Unity AI. So let's just go ahead and fix that and save our file. And then now all the errors should go away. Just like that. And we're going to go ahead and attach the unit AI to each of our prefabs, which are our movable entities. So you could just click on the first one and hold shift and click on the last one, and you could group select all of them within your hierarchy. And let's just go ahead and add a component, and this is going to be unit AI. So each entity 381 will have a unit AI. And I don't know if this is necessary. I don't think so. But we could just drag the entity 381 down into the property of that. So now, let's go ahead and test our code. So if we go ahead and click on the game tab, and then I'm going to rotate the camera down a little bit. If I push tab, then we can see that we've selected this entity. And if I right click, then we can see that I'm casting some rays onto the ocean or into the collider. And if I hold Alt, then I should be able to teleport this ship to that position. So I'm holding Alt and I right click, then we can see I teleported the ship to this position. But I accidentally sank the ship, and that's an honest mistake with inside the AI manager. So let's go ahead and open up the AI manager. And the reason why it sank is because I passed in the collider position, which is below the ocean, and we want the actual the position where we set y equal to 0. So I just have to change that, and I'm going to save my file. If I come back into Unity, I'm going to stop the playing, and I'm going to run it again. And this time I'm actually going to go ahead and select the tugboat so we could actually watch what's happening with the unit AI. So right now we can see the commands is a size of 0. And when I go ahead and add a command, we don't see anything immediately because teleporting just happens like pretty much in like 1 frame. It's like a really fast process, and then it gets removed from the commands. So I don't think we'll be fast enough to see it. Or yeah, we won't be able to see it. But once you start having like other commands that take a really long amount of time for the boat to travel to that position, then you'll be able to see it added onto this. And when you add like 4 commands, then you'll see the size increase to 4 commands. So that's pretty much everything in this tutorial. Another thing to note, if you click too close to the ship, it won't teleport it. So always try to click with some range. This is because the distancing set within inside the teleport command. And yeah, that's pretty much everything within this tutorial. So what's left up for you is to go ahead and implement the follow command, the move command, and the intercept command. So good luck with that, and I hope this tutorial was helpful.